Hello to all of you out there. So this is a pre-recorded video because it's a time of day that my house is normally full of children. And so I decided to go ahead and go with a pre-recorded. But hopefully there's a very high likelihood that I will be able to be on the chat during this video so that I can answer any questions for you. So please feel free to ask. Today, however, I'm very happy to be with you today to share with you my ideas about shifting security and sanity left by testing Terraform with InSpec. Okay, so I'm willing to bet that you've been on projects either in the past or maybe even right now where the temptation or even the expectation to go fast and deliver as quickly as possible was there. And it's very possible that testing was kind of seen as an extra or something that you would add later, maybe when you have a couple of slow sprints, but those slow sprints never come because you're always busy. So, and you might even be saying, well, what? I mean, we test already. We do Terraform plan and Terraform output. Isn't that enough? Or isn't anything more kind of a waste of time? We have so many other things we could be doing. And one could certainly argue those things, that's for sure. But those of you who have raced to get a Terraform project finished and then gotten stuck in a bottleneck of bugs and manual testing know, and I speak from experience, you know that you could have done more early on in the beginning of your project for your own sanity later on down the road. So trust me, your future self and your future teammates will thank you later for implementing testing early in the pipeline. Also, I was reading the site reliability workbook the other day, and this is a direct quote. The later in the product life cycle a problem is discovered, the more expensive it is to fix. SREs are specifically charged with improving undesirably late problem discovery, yielding benefits for the company as a whole. So if that isn't a resounding endorsement for early Terraform testing, then I really don't know what is. My name is Annie Hedgepeth, and I'm a cloud and automation engineer at 10th Magnitude. So my job includes a lot of configuration management as well as infrastructure as code development. And the tools that I found myself using the most have been Chef and InSpec for configuration management and Terraform for infrastructure as code provisioning. So as you may have deduced from this slide, my examples will be using Azure as my cloud provider of choice, but rest assured that anything that I'm doing here can also be done in any cloud provider and even on-prem. So I titled this talk, Shifting Security and Sanity Left by Testing Terraform with InSpec, because I'm gonna walk you through the following use cases for how to do just that. So number one, let's say you're provisioning a production environment. Well, you can kind of tack on an InSpec profile after that provisioning so that you can validate that it's in the desired state. Number two, you can also use InSpec for test-driven development, which means that you write a test, watch it fail, and then remediate that failure. Number three, you can use it for integration testing in a CI/CD pipeline by running those tests at each pull request and then not letting it merge into master unless it passes the test kitchen build. And then number four, you can also add all of your compliance testing early in those very early tests so that you don't find out much too late in the game that major changes for the sake of security and compliance were actually necessary. Okay, so some of you may never have used InSpec, so I'm gonna give you a quick crash course on what InSpec is. Okay, so you may have figured out by now that InSpec is an open source language for testing and auditing your applications and infrastructure. It compares the actual state of your system with the desired state that you expressed in the, and this is the very important part, easy to read and easy to write Chef InSpec code. It will detect the violations, then it will tell you in a report from which you can choose how to remediate from there. Kudos to you if you figured out why I added this picture of my son's foot. I told him the desired state to put on his socks for school. He said that he did, which he did. He put his socks on. Instead, however, of putting on his socks as one normally does, just like sometimes we code things, we expect it to be one way in one state, but then later, after it has built, we figure out that it's not in desired state. So as you can see here, tying your sock around your foot is not desired state for sock wearing. And this is something that you would want to audit and catch pretty soon on before you make your way all the way to school. Okay, so here is what an InSpec profile is structured like. At the top level, you have your profile. So an InSpec profile is what we're going to be talking a lot about. That's the package of InSpec tests. So your profile is made up of one or many controls, and it can also inherit other profiles and its controls. And each control is made up of one or many tests. So here's what a test looks like. And take note at the ease of which you can actually figure out what it's actually testing. So right here, we're using the Docker container resource. So we're saying, describe this Docker container called container. It should exist. It should be running. Its ID should not equal nothing. Its image should be BusyBox latest. So you can see it's just extremely easy to read, easy to write. Everybody knows what's going on here. We know what's being audited. Okay, so then you would take that test and you would nest it inside of a control, which also has a lot of metadata options. So those metadata options are especially useful and important for testing compliance because they can map directly to the compliance audits. So you say its impact is 6. You can title it based on sort of the compliance audits that you have. The description could be the rationale for that particular audit, et cetera. It could have tags. And then you can also output information from your Terraform run and use it as an attribute in the profile. So like here with the resource group name, let's say you had a resource group that had like a specific random number because you needed to have each of your resource groups be random. This would grab the output from your Terraform run and use it in the InSpec profile, like right here. I'm sorry, InSpec test. Okay, so now we take those controls and we put them in a controls directory. So here's our controls directory, and we nest them in a profile where you can also have a README, libraries for custom resources, files if you need them, and an InSpec YAML that defines your config for your actual profile. And then also where to store these things. So where do you put them? You can either have them locally, you can put them in Git, in a Chef supermarket, Chef Automate server. It's pretty flexible. Okay, so in our first use case, we talked about being able to use InSpec to validate a production deployment. So one way of doing this is simply to run the InSpec executable directly in the module as a local exec inside of a null resource at the end of the module. So here you can see it's running at the very end. So depends on your last resource provisioned. And then this is your InSpec exec, and it's running twice. The nice thing about this is that it will validate that your deployment is in its desired state. So if it's not, then you can alert somebody. That can trigger an alert that something went wrong with the deployment. And who knows what could have happened. Maybe somebody pushed some code that changed an access key somewhere to a storage account, and now that storage account isn't accessible anymore. So it doesn't have to be something that's in your code. It could have been something that happened outside of the module that messed up the provisioning. And you would want InSpec to catch that and to alert you on that because that's important. The other thing is that is really pretty cool that security teams would specifically appreciate is if you tacked on a profile at the end of this that defined all of your compliance audits as code. So as soon as you finish deploying, you can show your security team, look, this environment is in compliance. So some gotchas that you might need to be aware of, though, are that some of the resources may not be completely finished. You need to make sure to orchestrate this so that you know that everything is finished, doing what it's supposed to be doing to get into the desired state before you actually test the desired state. For example, let's say you had Chef running some post-provisioning configuration on a node. Well, you need to make sure Chef is finished before you test that Chef did what it was supposed to do. Stuff like that. So just make sure to sort of orchestrate it properly. Also, an InSpec profile has to run per target So you'd be able to run the executable against each target separately. So right here, -T means target, and it's targeting an Azure subscription. And then this target is targeting a Linux box. So, and you can see that these are two different profiles too. So you can't just run one InSpec executable, you have to run one per target. All right, so, oh, and then another thing to note is that you wouldn't want to use this method for test-driven development. It can be very cumbersome. So even if you used a separate TFRs file specific to your test environment, there's really no way to know, there's really no way to 100% know that you're not going to mess something up with your state file or ruin something that's in production or whatever. Even if you completely isolate it and you know that you're safe, it's just not a risk that you should take because you don't know who's going to be running this down the road. So you want to be able to really isolate out your test environment. Also, it's just cumbersome to run each time that you want to run a test because depending on the kind of failure that you get, whether you don't know whether it's going to be a Terraform failure or an InSpec failure, so it's confusing to know sort of which what thing is causing the failure. So I don't recommend this method, running the InSpec executable inside of a local exec. I don't recommend that for test-driven development, but I do recommend it for production validation and compliance auditing. A better solution for that, for test-driven development of Terraform modules, is Test Kitchen. So now Test Kitchen is most popular for being used with Chef as a way to spin up a test node and then run your Chef cookbook on it and then test it with InSpec. It's a nice little sandbox that provides the perfect isolated environment to do test-driven development with your Chef cookbooks. In the same way, we can provide this lovely isolated sandbox for our infrastructure provisioning by using the Kitchen Terraform driver. And a side benefit of that is that it is a great way of using Test Kitchen, Test Kitchen is a great way of onboarding new team members to using your modules, your Terraform modules. You want them to run them to be able to familiarize themselves with them, but you don't want them to, you don't want to risk them messing anything up that is even in your regression environment or in your production environment. So you want to give them their own sandbox to run these things with to get familiar. Okay, so the driver in Test Kitchen is what will be used to create the resources. So for this, we want to be able to build with Terraform. So we'll be able to use the Kitchen Terraform driver. It's built with Ruby. It uses Bundler. And so you will need Ruby installed. So then you just have to install the Kitchen Terraform gem to use it. And again, if you're familiar with Chef and Ruby and already have this installed, then it's really ideal for you. Oh, and shout out to New Context, a consultancy who developed this, and then Aaron Lane, who used to work there but continues to maintain it now, which is really a great benefit to all of us that use it. So thank you. Okay, so the way that Kitchen works is that you basically nest a Kitchen module inside the module that you're testing. And the isolation inside that nest insulates it enough to create a nice little sandbox environment that I keep talking about. So these files that are highlighted in red here, or boxed in red, they make up your main module, right? And of course, this is a very bare bones module. You're just creating a VM, you've got some variables, some TFRs, output, and a README. That's it. This could obviously be as complex as you want it to be. But it illustrates that this is the module that you're testing. It's at the top of the tree in the base of the module, the root of the module. Then nested within this module, you'll have your test directory. And that will have your fixtures directory. And the fixtures directory houses your Test Kitchen module. And your Test Kitchen module will have all of its own variables, and it can even have different dependencies. Let's say that it needs to be put into a particular VNet. Well, you don't want it to go into your production VNet, you want it to go into your regression VNet. So you would put its own dependencies there, or you create one on the fly, or whatever. You can put all your own dependencies in that module. Okay, so here is a look at this test kitchen's main.tf. As you can see, all it is a module that's wrapping the root module. So my root module is called Test Kitchen Terraform, which is a little confusing for this demo, I admit, but you get the point. And it has all of its own variables. So it's using a completely different subscription even. So this is completely isolated from anything that's going on in production or anywhere else. Okay, so below your fixtures directory is your integration folder, and that houses your InSpec profile. And important to note is that your kitchen YAML, which is the configuration file for your test kitchen, this also sits at the top of the tree or in the root of the main modules directory. I think I said that right. This does not go in your test directory. This goes at the root of the main module. Okay, so here is what your kitchen configuration file will look like, what I just showed you, the kitchen YAML. As you can see here, that the driver is Terraform. So the Terraform driver is what manages the state of the Terraform root module. And you can see here that the root module is directed to be the test kitchen that's nested inside of the fixtures directory. And then the Terraform provisioner uses the Terraform driver to apply changes to the Terraform state. Okay, so then the Terraform verifier is what uses InSpec to verify the Terraform state. A kitchen instance is verified by iterating through the systems and executing the associated InSpec controls against each target. So in each of these systems, you can see that the backends are different and how to connect to those backends is different. So for the first one, you can see we're targeting the actual VM that we created in our Terraform module. And we're going to SSH into it in order to run the necessary tests. And this you can't really do with a lot of other Terraform testing platforms out there or frameworks out there, because this is actually going into the node and testing that the configuration is the desired state. Okay, so then for the second system here, we are targeting Azure, our Azure subscription, and you can see it uses a different set of controls. The VM system is using VM config controls, and the Azure system is using resources controls. And this has a lot less sort of config around actually getting into that subscription because Azure uses environment variables for that. So depending on whatever your cloud is, you'll have different different ways of connecting there. Okay, so I told you that you can test two different systems, Azure and VM in our example, right? Kitchen Terraform calls them systems and InSpec calls them targets. But there is a little trick that I had to learn to get this to work properly. You have to do two things. So first, make sure that your InSpec config, in your InSpec config, you're supporting both of the platforms that you're testing. You can see here that we're going to support both Azure and our Linux OS family. Then here in the InSpec profiles directory, you can see that we lumped both systems tests into the same profile, but InSpec is going to fail if, whoops, sorry about that. InSpec is going to fail if you have controls in an InSpec run that aren't for that target or system. So go to your kitchen config here. Remember, we're back here at the kitchen config, and make sure that each system is only running the controls for that particular system. So you can see here, the VM config InSpec controls are being run on the VM target, like I said a minute ago, and the resources InSpec controls are being run on the Azure target. If you just left this blank and you didn't specify which controls were being used, then it would fail because it's going to try to run all of the controls and it doesn't know how to run those certain controls on the opposite target. It just won't work. It won't compile. Another consideration that I really wish I had time to explain here, but I don't, is something called profile inheritance. So this is a way that you can run other profiles from this profile. So I mentioned it right here. So if this is something that you're interested in, then Google InSpec profile inheritance, and it'll kind of show you how you can find a lot of good blog posts about how to let your profile inherit another profile. For example, that security and compliance profile that I keep talking about. Okay, now's the fun part. So you can start running Test Kitchen and get your sandbox up and testing after all of that's figured out. So the first two commands that we're going to talk about actually are just wrappers around the Terraform commands. Kitchen create is the kitchen command, and it just maps directly to Terraform init. And then kitchen converge is going to set up a new workspace. It's going to validate the configuration files, and then it's going to run Terraform apply. Then to run your tests, you're going to run kitchen verify in order to run the InSpec executable on your targets. And then after all that, you don't want your environment to hang around. So you would run kitchen destroy, and then that would destroy all of your all of your kitchen resources. And this is going to use the test kitchen modules TF state file, not anything else. You only want to delete your kitchen environment. And so that's just that added layer of protection. All right, so we're going to go into these in a little bit more detail in our fake demo. I wish I had time to do a real demo for you, but I don't. So I'm just going to run you through what it will look like. Okay, so this is what kitchen create will look like. And you can see here that I'm running it inside of Ruby's bundle exec. So bundle exec, kitchen create. And I'm running it from the main modules root directory, remember, not the test directory, which is, again, confusing because I called it test kitchen Terraform. And here you can see that kitchen create is, like I said, just a wrapper around Terraform init. So it's going to initialize the working directory containing Terraform configuration files inside our test directory. And then after that runs successfully, you'll move on to kitchen converge, which you can see here will first run Terraform workspace select, which will select that new workspace that we just created in our test kitchen directory so that we can do stuff in it. And then we're going to run, no, we're not going to run, kitchen converge is going to run Terraform get update to download and update the modules mentioned in the root module, which in this case is our test kitchen module. Then Terraform validate to just verify that the syntax is good, the variables work, etc. And finally, it runs Terraform apply from that same test kitchen directory and starts provisioning a test kitchen environment of our root module. So if we scroll down, we can see here that it's finished and it gave us our Terraform output. Yay, it worked. My fake demo worked. And now my favorite part. So actually testing our module with kitchen verify. So we run kitchen verify, and remember, it's going to run InSpec against two different targets because we told it in our kitchen YAML, run it against the VM and against the Azure subscription. So first, it's going to run all of the VM config InSpec tests against that target. And so now we've validated, see right here, so easy to read and beautiful. The user, TK user, home is expected to equal home/TK user, and that passed because it's got this pretty little check mark. And the owner of that directory is supposed to be TK user. So yay, it passed. If this failed, it would just stop right there and not move on to the next one. So that's, I believe that that's true. I'm 98% certain that that's true. So then it moves on. Oh, another thing about this. Again, this is super bare bones, but anything that you do post-provisioning with your configuration can be tested in this. And not only that, but let's say that you want to make sure that it's using the right image. Then do some tests in there that test that, you know, something in that image that you want to be using is set properly. We want to make sure we're using the right image, and we want to make sure that any post-provisioning, whether it be through Chef, Puppet, Ansible, Cloud Init, etc., we want to make sure that all of that is in the desired state. Okay, so next we're going to target our Azure environment itself and then validate that all of the resources that we created exist. Here we can see that the VM exists, yay, and that there are network security groups and rules. There's a virtual network that we created and that exists, and it's in the region that we want it to be in. This can also be way more complex based on your environment, but this is just your super bare bones demo. So like I said earlier, there are a myriad of different InSpec resources to be used for all of the major cloud providers and different platforms, Linux, Windows, Docker, whatever you want. And really anything that you can run a command to check, then you can either InSpec already has a resource for it, or you can create your own custom resource. So it's extremely flexible. Okay, now that we have a successful validation, let's destroy all of our kitchen resources because we don't want to pay for them to hang around, right? So another thing to note is that you can run kitchen converge and kitchen verify a bazillion times back and forth until you get it right and until all of your tests are passing. And that is the beauty of test-driven development. You write your failing test, or you write your test, watch it, run it, watch it fail, and then do your remediation and then watch it pass. So once it passes and once you're happy with it, then you can run kitchen destroy, and it is going to again, select your test kitchen workspace, keeping it isolated and sandboxed and safe, and then it's going to run Terraform destroy from the safety of your sandbox. And when all is done, you don't have to worry about keeping any of these environments around. So now that you know a bit about InSpec, we can go back to this slide and then match those use cases with the method for running InSpec. Okay, so if you want to validate your validate and run compliance audits on a deployment, then you can run an InSpec profile at the end of your module with your local exec provisioner. And if you want to use test-driven development practices in the development of your Terraform modules, then use those tests in a pull request build, and then test kitchen, oh, sorry. If you want to use test-driven development practices in the development of your Terraform modules, then use those tests in a pull request build. Then Test Kitchen is going to be your friend for that. So local exec for the provisioning, Test Kitchen for test-driven development or CI/CD. Also, though, you can add those compliance profiles that I keep talking about in those Test Kitchen tests if you want to, and the pull request builds to make sure that nothing gets merged that would put you out of compliance. That would be really nice so that you don't find out way too late in the game and then have to change a bunch of stuff. Okay, so I really hope that this helps making your terraforming more sane and more enjoyable. These are some extra additional resources. This demo is in my GitHub, and I also blogged about it. And there, that second link is my blog. So feel free to take a look at those and hit me up with any questions that you might have. And of course, you can familiarize yourself with the Kitchen Terraform plugin on their GitHub page, which is right there. It's been such a pleasure speaking with you today. Please feel free to reach out if you have any questions, and enjoy the rest of the amazing HashiTalks coming at you. Thank you.